Okay, so let's have a look at the solutions to assignment 78. Okay, first question, convert the following quadratic function to vertex form and then calculate coordinates of the vertex. The y-intercept, x-intercept, if any, then sketch the graph of the function, clearly labeling the coordinates of the vertex. The y-intercept, x-intercept, if any, and the axis of symmetry on the graph. Okay, first question. First of all, let's convert it to a vertex form. So note here the leading coefficient is not 1. So in this case, usually we'll put it in front of the brackets, and then the original function is equivalent to this one. Y equals -5 times x squared plus 6x, right? Then plus 4. Sorry, -4. And then, so note here we have 6x. 6x can be written as 2 times x times 3, right? So the other term is 3. So let's try x plus 3 squared. Okay, then on a scratch paper, if you extend it, you will get x squared plus 2ab, which is 6x, then plus b squared, which is 9, right? Because there is no 9 in the original expression, then we need to subtract it in order to have the first two terms exactly the same way as the original expression. Then copy the rest of the expression, which is -4. And therefore, this is equivalent to y equals -5 times x plus 3 squared minus 13. Okay, in order to convert it to a vertex form, we then need to put -5 back in the brackets, which is -5 times x plus 3 squared, then plus 65, right? So when you have a negative symbol here and the negative symbol here, you need to pay special attention, because negative and negative will get you positive 65. Okay, so this is a vertex form, right? So this is our h, this is our k, and this is the leading coefficient a. All right, so we can now conclude the coordinate of the vertex is -3 and 65, right? Okay, and the second piece of information is the y-intercept. That means we need to let x be 0. If x is 0, let's put it back in the original expressions, and y is apparently 20, right? Therefore, the y-intercept, you can say it is 0, 20. Okay, next, the x-intercept, that means we need to let y be 0, right? And if y is 0, that means 0 equals -5 times x plus 3 squared plus 65. This means x plus 3 squared needs to be positive 13, right? Which means x plus 3 is either positive or negative square root of 13. So there are two roots. X can be positive, -3, then positive or negative square root of 13. And therefore, the two x-intercepts are -3, negative square root of 13, 0, and -3, positive square root of 13, 0, right? And last is a leading coefficient a. A is apparently -5, right? Which is less than 0. So this function appends down. Okay, so we have gathered all the key information regarding this function. Vertex is here, y-intercept, x-intercepts, and direction. Then we can sketch its graph, right? X-axis, y-axis. and vertex is -3, 65, which is around here, right? And a 0, 20 Y-intercept. And here is the first x-intercept, which is -3 minus square root of 13, 0. And apparently the other x-intercept, -3 plus square root of 13. This is apparently greater than 0, right? So you need to mark it to the right of the original point. Okay, and this is axis of symmetry, which is x equals -3. And then we put the expression of the function next to this curve here. Okay, I'll give you some time to have a look at this question and let me know if you finish and we can proceed, okay?
Okay.
Done? Okay. Let's see question 2. All right, so first of all, let's convert to the vertex form. And note here, leading coefficient is not 1, so let's put it in front, which is -2 times x squared then plus 6x, right? And again, you have 6x, so let's try x plus 3 squared, right? Okay, so this is equivalent to y equals -2 times x plus 3 squared. And of course, if you expand it on a scratch paper, it's x squared plus 6x plus 9. Because there is no 9, we need to subtract it from the original expression. And this is further equivalent to y equals -2 times x plus 3 then squared, then positive 18, right? Okay, and then this is already in a vertex form, right? So we can conclude that the vertex has the coordinates of -3, then positive 18, right? Okay, next, let's find its y-intercept. So basically, we can let x be 0 and find its y. So if x is 0, apparently y is 0, right? Therefore, the y-intercept is 0, 0. Next, let's find its x-intercept, if any. So basically, we let y be 0 to solve x. So if y is 0, that means -2 times x plus 3 squared plus 18 is 0, right? That means x plus 3 squared is 9, which means x plus 3 is either positive or -3, right? Which means x is either 3 minus 3, that is 0, or x is -3, -3, which is -6. And therefore, the x-intercepts are 0, 0, and -6, 0, right? And last, let's check the leading coefficient a. A is -2, which is less than 0. Therefore, this function, the curve of the curve of the parabola opens down, right? Okay, so we have gathered all the key information. Vertex is here, y-intercept, x-intercepts, and direction. Then we can sketch its graph. Okay, x-axis, and then y-axis. First of all, the vertex -3, 18 is about here, right? And then one of the x-intercept is 0 here. Apparently, the y-intercept is also here. So basically, it has a shape like this. Vertex -3, 18. And one of the x-intercept is -6, 0. The other one is 0, 0. Okay. And axis of symmetry is x equals -3. And then let's put the expression of this function next to its curve. Okay, so this is a complete sketch of the curve of this function. We must spend some time, have a look at it, and let me know if you finish, okay?
Okay.
All right, let's see the next one. Next one, we can just follow the same method. First of all, convert it to the vertex form. The original expression is equivalent to y equals -4, put it in front, right? So what's left in the brackets is x squared -4x, then -5, right?
Yeah.
Okay. Then next, because we have a -4x, which can be rewritten as 2 times x, then times -2, right? So you need to try the other number is -2, so that's basically you can try x minus 2 squared, right? Okay, so let's see what will happen. Y equals -4 times x minus 2 squared, right? And if you expand it on scratch paper, you will get x squared minus 4x plus 4. First two terms are exactly the same with first two terms here, but there is no plus 4, so it means subtract it here. Then copy the rest of the expression. Okay, so this is equivalent to the original expression. Actually, they are the same, right? And y equals then -4 times x minus 2 squared, -9, right? And actually, we can use the equality symbol. Y equals -4, then times x -2 squared plus 36, right? And apparently, this is a vertex form. So the vertex has a coordinate of 2, 36. Then let's find its y-intercept. That means let x be 0 to find y, right? If x is 0, back to the original expression. If x is 0, apparently y is 20, right? And therefore the y-intercept is 0, 20. And then next, let's find its x-intercept. That means let y be 0 and put it here. If y is 0, that means -4 times x minus 2 squared plus 36 equals 0, right? Which means x minus 2 squared equals 9. Therefore, x minus 2 could be either positive or -3, right? And therefore, x is either 3 plus 2, which is 5, or -3 plus 2, which is -1, right? And therefore, the x-intercept, I'll write it here, are 5, 0, and -1, 0, right? Okay, last, the direction. So leading coefficient A is -4, which is less than 0. So it opens down, right? Okay. All right, again, we have gathered all the key information: vertex, y-intercept, x-intercepts, and direction. So now we can draw the sketch of the graph of the function. Y-axis, x-axis. First of all, the vertex is 226. So 226 is around here. And then y-intercept is 0.20. 0.20 is about here. And the one of the x-intercept is 0.1, so it's around here, right? So basically, the left branch should look like this. Oh, sorry. And this is an x-intercept, -1, 0. And the other x-intercept is here, which is 5, 0. Again, apparently this is not to the scale. As long as you keep all the elements in their correct relative positions, you'll be fine, okay? And this is the axis of symmetry, which is x equals 2. Then let's label the expression of the function next to its curve. Okay. All right, so please have a look at this question and let me know if we can go to the next one, okay?
Okay.
All right, then let's have a look at the next question. The question 2, for each of the following functions, state A, the coordinates of the vertex, B, the direction of opening, C, the min or max value of the function, if any, and D, the number of x-intercepts. Okay, so in this question, it does not ask you to sketch the graph, right? But answer the questions based on the coordinates of the vertex. So we can use the shortcut method to calculate the coordinates of the vertex first, right? So remember that for any quadratic function that is in the general form, the vertex, the coordinates of the vertex can be calculated using this formula, right? Vertex is, first of all, the x, the coordinate of the vertex is -b over 2a, right? And the y coordinate of the vertex is 4ac minus b squared over 4a, right? These are the shortcut to calculate the vertex coordinates. Okay, so first of all, let's have a look at question 1. And apparently, this is our a, which is 2. This is our b, which is -4, and c is -12, right? So as long as you have identified the a, b, and c 3 coefficients, the rest of the task seems a little easier. So the vertex, I'm calculate using -b over 2a, right? This is x coordinate, which is b is -4. And 2a is 2 by 2, and this will give you 1. Then the y coordinate is 4ac minus b squared over 4a. Okay, 4ac is 4 by 2 by -12, right? And negative b squared apparently is 16, and over 4a, which means 4 by 2. And this will give you -112 over 8, right? which is -1, 4, -14. All right, so the vertex is not appropriate to write it here. So the vertex has coordinate of 1, 14. All right, that answers the first question, coordinates of vertex. Then the direction of opening. That depends on the value of the leading coefficient A, right? And because A is 2, which is greater than 0, therefore it opens up. That's the direction of opening. Okay, C. Because it opens up, so it will have a shape like this, right? And there is a minimum point on the curve. Therefore, the minimum value is the y coordinate of the vertex. So minimum value is -14. Okay, last, the number of x-intercepts. So that depends on the relative positions of the vertex and the x-axis, right? And apparently, vertex has a y coordinates of -14, and it must be below the x-axis, right? If the vertex is below the x-axis, and it opens up, then it must have two x-intercepts, right? Okay, so the question of D, number of x-intercepts is 2, so there are 2 x-intercepts. Okay, any questions?
No.
Okay, then let's have a look at question 2. Okay, first of all, identify A, B, and C. So A is 3, B is 12, right? And C is 17. So first of all, let's calculate the coordinates of the vertex. First of all, the x coordinate, which is -b/2a, which is b is 12, 2a is 2 by 3, so we have a -6. Oh, sorry, -2, right? And y coordinate is 4ac minus b squared over 4a. And 4ac is 4 by 3 by 17. Negative b squared is 12 squared, which is 144, and over 4a, which is 4 by 3, right? And result of this is, let's calculate this using the calculator. So that's 12 times 17, then minus 1 for 4, which is 60 over 12. And the y coordinate is 5, right? So therefore, the vertex is -2, 5. That's the coordinates of the vertex. And then B depends on the leading coefficient A. And apparently A equals 3, which is greater than 0. Therefore, it opens up, right? Because when A is greater than 0, it opens up. So C, min or max. Again, if it opens up, it will have a minimum value, right? So minimum value is just the y-intercept of the vertex, which is 5. And D. Well, D depends on the relative positions of the vertex and x-axis. So here, the vertex has a coordinates of -2 and 5. So it must be above the x-axis, right? That means there won't be any x-intercepts because when the vertex has a y coordinate that is more than 0, and then the curve opens up, it will never intersect with the x-axis. Therefore, there is no x-intercepts or 0 x-intercepts. Okay, so please have a look at this question and let me know if you finish and I can proceed. Of course, you don't have to sketch the curve here. You can just do it on a scratch paper, right?
Yeah.
All right, then let's have a look at question 3. All right, first of all, the coordinates of the vertex. -2, -b over 2a is -b is 10, right? 2a is 2 by 5, so x coordinate of the vertex is -1. Then calculate 4ac minus b squared over 4a. So 4ac is 4 by 5, then minus b squared is 10 squared, right? Then 4a is 4 by 5. And this is 100 minus 100, which is 0. And therefore, the coordinates of the vertex is -1, 0, right? Okay, the direction of opening. Let's check the leading coefficient. Leading coefficient is 5, which is greater than 0. Therefore, it opens up. And see the minimum or maximum value. So because it opens up, it must have a minimum value at the y coordinate of the vertex, right? Therefore, the minimum value is actually the y coordinate of the vertex, which is 0, right? And B, how many x-intercepts? So let's check the relative positions between the vertex and x-axis. The vertex has a coordinates of 0, of -1, 0. And apparently it will intersect with the x-axis, right? And there is only one intersection point here. So therefore, there is only one x-intercept. Okay. Any questions?
No.
Okay. Let me proceed to the next one. All right, question 4. First of all, calculate the coordinates of the vertex. Again, -b over 2a is the x coordinate. So -b is 7, right? And 2a is 2 by -1, which is 7 over 2. And then y coordinate of the vertex is 4ac minus b squared over 4a. And this is 4 by a is -1. And by c is -10. Minus 49 over 4a, which is 4 by -1, right? And this is 40 minus 49 over -4, which is 9 over 4, right? And therefore, the vertex is 7 over 2 and 9 over 4. Excuse me. Okay, so this is the coordinates of the vertex. Then let's check the direction of opening. That depends on the leading coefficient a, right? And apparently a is -1, which is less than 0, right? If the leading coefficient is less than 0, that means it opens down. Okay, so see, basically, if it opens down, it will have a maximum value at the vertex, right? So the maximum value of the function can be obtained at the y coordinate of the vertex, which is 9/4. That's maximum value of this function. And the number of x-intercepts depends on the relative position between the vertex and x-axis. So the vertex has a coordinate of 7/2 and 9/4, right? Which is apparently above the x-axis. So if it if the vertex is above the x-axis and it opens down, that means it must have two intersections between this curve and x-axis. Therefore, there must be two x-intercepts, right? Okay, so have a look at this analysis and let me know if you finish, and then we can proceed.
Okay.
All right, next one. Again, first of all, the vertex. Negative b over 2a, which is negative b is 24, and 2a is 2 by -4, right? And this you will get 3. And the y coordinate, which is 4 by -4 by -38 minus 24 squared over 4 by -4, which you will get -2. Therefore, the vertex is 3, -2, right? Okay, next let's check the direction of opening. That depends on the leading coefficient A, which is -4. And apparently this is less than 0 and it opens down or downwards. See? If it opens downwards, then there must be a maximum value in the function, right? That's the vertex. So the maximum value of this function is y coordinate of the vertex, which is -2. Okay, and question D. That depends on, again, the relative positions between the vertex and the x-axis. And in this question, apparently the vertex is under the x-axis, right? And if the vertex is under the x-axis and it opens down, that means it is not possible to have any intersection between this curve and the x-axis. Therefore, there are 0 x-intercepts. Okay. Any questions?
No.
No? Okay, good. Let's see question 6. Again, first of all, the vertex. Negative b is -12. 2a is 2 by -3. That's the x coordinate of the vertex, which is -2, right? And then the y coordinate of the vertex. Which is 4 by -3 by -12 minus 144 over 4 by -3, which is 0, right? And therefore the vertex is -2, 0. That's the first question. Next one, the direction of opening depends on the value of A. A is -3, which is less than 0. So it opens down. And next, if it opens down and Okay, if it opens down, it must have a maximum value at the vertex, right? And the maximum value is actually the y coordinate of the vertex, which is 0. And last question, let's check the relative position between the vertex and x-axis. Vertex is 0 to is -2, 0, and apparently this point is on the x-axis, right? That means this curve will intersect with x-axis, and there will be only one intersection point. So that means there is only one x-intercept. Okay. All right. Any questions?
No.
Shall we proceed? Next one. Okay. Next one. Okay, this time you are given a sketch of a graph of a quadratic function, right? And question asks you to find an expression of such a quadratic function. So note here, we know the vertex, right? We know the coordinates of the vertex. And then a point on the curve. So if you know the coordinates of the vertex, you can, first of all, use a vertex form to express such a function, right? So let y, okay, so let's say suppose the function is y equals, what is the vertex form? Vertex form is y equals a, which is the leading coefficient, right? Times x minus h, right? H is x coordinate of the vertex, so x minus 2. Then plus k. K is the y coordinate of the vertex, which is -9, right? Which is y equals a times, sorry, lost a power of 2 here. I missed the power of 2 here. So x plus 2 squared, then minus 9. This is a vertex form of the function, right? Note here, there is only one unknown coefficient, which is a. So that means we only need one point, and then we can plug it in to get the value of a, right? Because it passes -4, -5. Therefore, we can plug it back to solve the value of a, right? Therefore, -5 equals a times -4 plus 2 squared -9, right? Therefore, it means -5 equals 4a -9. That means 4a equals 4, which means a equals 1, right? Therefore, the expression of such a function is y equals x plus 2 squared -9, right? Or you can also simplify it. If you simplify it, it will equal x squared plus 4x then -5, right? This is the final solution. Okay, so please have a look at this question. And let me know if you finish, okay?
I'm done.
All right, good. Next one. All right, so this time we don't know the coordinates of the vertex, but instead we know the coordinates of 3 points on a quadratic curve, right? And the question asks us to find an expression of such a quadratic function. Okay, so suppose the expression of this function is y equals ax squared plus bx plus c, because we don't know the coordinates of the vertex, so we can use a general form of the quadratic function where a is not 0. And in order to solve a, b, and c, we need at least 3 equations, right? And 1 point corresponds to 1 equation. If you plug that in, plug that point in, you will get an equation, right? So first of all, -1, -5 on the curve. That means we can plug it in, right? So -15. Okay, let's write it this way. So basically 3 points on the curve means we can plug these 3 points back to the equation, right? So first of all, -1, -15. This means -1 squared times a, then plus b times -1 plus c equals 15, right? Which means a minus b plus c, or should equal -15, not positive. Should equal -15. Then the second point, 2, -3. That means 2 squared times a plus b times 2 plus c should equal -3. Then simplify it, you will get 4a plus 2b plus c equals -3. Then the third point, which is 3, -7. That means a times 3 squared plus b times 3 plus c equals -7. So 9a then plus 3b plus c equals -7, right? So let's label them as 1, 2, 3 to facilitate our discussion. First of all, we can use number 1, number 2 to eliminate c, right? And then to use number 2 and number 3 to eliminate c. Then we can solve a and b, right? Okay, so in order to eliminate c, we can use 2 minus 1. This will give us 3a minus 3b equals 12, which can be simplified to a minus b equals 4. And let's label it with 4. Then we use the last 2 equations to eliminate c as well. We can use 3 minus 2. And we'll get 5a plus b equals -4, right? And let's label this with 5. Then we can use 5 -5 subtracted by 4, right? Which you will get or made a mistake. This should be a plus sign, not subtraction. Should be a plus b equals 4. Then 5 minus 4 will get us 4a equals -8, right? And therefore we can solve the value of a is -2. So let's call this 6. Then we can put 6 back into equation 4 to solve the value of b, right? Currently b is 6. And then let's label this with 7. Then we can put 6 and 7 back into equation number 1 to solve the value of c, right? Okay, 6, 7 to equation number 1. This will give us -2 minus 6 plus c equals -15, which we can solve C is actually -7, right? Okay, so far we have successfully solved A, B, and C. That means we have solved the expression of this equation. And therefore, the expression of such an equation is y equals -2x squared, then plus 6x, then -7. This is our final solution. Okay, so please have a look at this solution and let me know if you finished and we can proceed, okay?
Okay.
All right, good. Then let's see the next one. Actually, question 5 is very similar to question 3, except that you are given not a graph, but an English statement, right? Again, this time you know the coordinates of the vertex and a point on the curve. Then the question asks you to find the expression of such a quadratic equation, right? Again, so because we know the coordinates of vertex, so we can say, suppose the expression, the function is, we can use a vertex form, right? Vertex form is y equals a times x minus h squared plus k. So h is the x coordinate of the vertex, so h is 3. Then k is 0, right? We don't know the value of a. So suppose the function is y equals a times x minus 3 squared plus 0. That is, this can be simplified to y equals a times x minus 3 squared, right? And the task is to solve the value of a only. And to solve the value of a, we need to know a point on the curve, which is here, right? So basically, 0, 18 is on the curve because it's the y-intercept. Y-intercept must be a point on the curve, right? Because 0, 18 is on the curve of the function or the graph of the function. Therefore, we can insert this point back to this equation here, right? So when x is 18, this is a times 18 minus 3 squared is y is 0, right? Oh, sorry, a mistake. When x is 0, y is 18. When x is 0, that means a times 0 minus 3 squared is 18, right? Y is 18. Okay, so that means a times 3 squared is 9, is 18. So a is solved to be number 2, right? And therefore the expression is y equals 2 times x minus 3 squared. And then this is our expression. Okay, have a look at this question and let me know if you are ready for the last question.
Okay.
All right, last question. Question 6 is actually similar to question 4, right? Except this is an English statement rather than a graph. Again, this time we do not know the vertex, but we know 1, 2, 3 points on the curve, right? X2 x-intercepts. X-intercepts apparently are points on the curve, right? Y-intercept is also a point on the curve. So again, we can say, suppose the function you are looking for is y equals ax squared plus bx plus c, where a is not 0. Because we don't know the vertex, we can use a general form quadratic function, right? And in order to solve the a, b, and c, we need 3 equations. And 1 point corresponds to 1 equation, right? Okay, because -2, 0, 2, 0, and 0, 20 are on the graph of this function. Therefore, we can plug them in, right? So first of all, when x is -2, that means a times -2 squared plus b times -2 plus c equals 0, which means 4a minus 2b plus c is 0, right? And then when x is 2, y is 0, that means a times 2 squared then plus 2b plus c is also 0. This means 4a plus 2b plus c is 0. Next one, x is 0, y is 20. So that means a times 0 plus b times 0 plus c equals 20, which means c equals 20, right? And let's label them with 1, 2, and 3. Apparently, c is already solved, which is 20, right? So the remaining task is to solve a and b, which is not very difficult. So we can use number 2 minus number 1, right? Number 2 minus number 1 will give us 4a cancels with each other, 2b minus 2b, which is 4b, c minus c cancels with each other, so 4b equals 0, right? So that means b is 0. Okay, so if b is 0, let's call this 4. Let's plug 4 into either a or either 1 or 2, right? For example, if we plug it into equation 1, we'll get 4a plus minus 0 and then plus 20. So actually, we also use equation 3. So 4a plus 20 equals 0. That means 4a is -5, right? Okay, so that means we have successfully solved C and B and A, right? And therefore we can make the conclusion. Therefore, the expression of this function is y equals -5 x squared plus 0x, which is 0, right? And then plus c. C is 20. Well, this is our expression. Any questions?
Okay.
All right. I have put this note onto Google Classroom. You can refer to my notes after the class, okay? And I'll let you know when the next assignment is available. All right? If there's no questions, you are free to leave. Have a nice evening.